So this is part 2 of 10-part series questions of MCAT. So the question is asking, what is the stereochemical relationship between these two compounds, right? So if we look at these two compounds, what we see is that this carbon center at C3 on compound 1 and the carbon center at C3 for compound 2 has a difference in the orientation of where OHs are placed, right? In compound 1, OH is on the left, and in compound 2, OH is on the right, which clearly means that the stereochemistry at that carbon center, right, is different for compound 1 as compared to compound 2. In fact, they are the opposite, right? So if the stereochemistry of one of the carbon center is opposite, but the stereochemistry of all of these centers, the rest of the centers, remain the same, but only for one of the carbon center, it's different, right? That would make the relationship between those two compounds as diastereomers. So if you have two compounds, and if in the second compound retains the stereochemistry of all the carbon centers, then those two compounds are, first of all, you would call these compounds exactly the same, right? And if all of the carbon centers switch stereochemistry, meaning if all of them are going in a different stereochemistry, if all of them were switching from R to S or S to R, then you would call them enantiomers, right? But only if some of them switch stereochemistry, not all of them, they're called diastereomers. So you can say if only some switch stereochemistry, not all. Chemistry, not all. They would be called diastereomers. So in this case, we see that only one carbon center is switching the stereochemistry at that carbon center, right? Because only one OH is changing the orientation. That's what's changing the stereochemistry, but every other atom has similar placements of those other atoms. That is going to make it a diastereomer, right? The fact that they're carbohydrates, and in a carbohydrate, if you see that one carbon center, if only one carbon center switches the stereochemistry over, that carbohydrate, especially that carbohydrate, is called an epimer. So then the relationship between 1 and 2 is that they are diastereomers, but they're also epimers because of the fact that they're carbohydrates, right? That's why C then is the correct answer for this problem.